Hi, welcome back to this channel. Today we are going to continue with the ionic radius. So just recall back in last video we discussed about the trend across the period, which the size is getting smaller, and also trend down the group at where the size will become bigger. And the third one is the trend across the transition element, which does not change significantly. Okay, and in this video, we are going to focus to compare the size of atom and its cation. Means that after the atom lose electron, will form cation. So for example, sodium atom with sodium ion. So what is the difference between these two species? Okay, then next will be atom with the anion. For example, chlorine and chlorine ion, chloride ion. And then lastly, we are going to discuss about isoelectronic species. At where means they have same number of electron or consider same electron configuration. Okay, now let's continue when we want to discuss the atomic radius with its ionic radius. So this diagram is very obvious. We can see that lithium atom has the bigger size if compared to its cation. Okay, so lithium have bigger size than cation, while fluorine atom has smaller size than fluoride ion. Okay, this is the general information that we get from this diagram. Cation always smaller than the atom, while anion is always larger than the atom. Okay, let's look in detail how we're going to compare the size between the atom and also its cation. So generally, we all already know cation is formed when electrons are removed from the valence shell. So for example, if we have sodium, it will have the electron configuration up to 3s1, while for the Na plus will up to only 2p6. So based on these two electronic configurations, so it is very obvious that the main difference is the number of shells occupied by electrons. So because of this difference that we observe, so we are going to discuss the difference between the size of the atoms and its cation by using the factor shielding effect. The greater the shielding effect means that the weaker the attraction between nucleus and valence electron. Highlight here, you must mention valence electron because the size means the definition of the radius means the distance between nucleus and valence electron. Okay, so that's why we have to emphasize the term valence electron in your explanation. Due to the weaker attraction, so the valence electron will be further from the nucleus, and this will cause the size of the sodium always larger than Na+. Now is the term compare the size of the atom and its anion. So again, anion is formed when the electrons are added to an atom. For example, phosphorus atom have the electron configuration up to 3p3, while for the p3 negative up to 3p6. So based on this electron configuration, we have the idea that the electron actually are added into the same shell. So means that the shielding effect is not significantly changed between P and P3 negative. So in this case, we are not going to use the factor of shielding effect. But then because of the electron are adding in the same shell, so we will emphasize on the mutual repulsion between the electrons. Okay, mutual repulsion means the penolakan antara electron. So this will cause the valence electron push far apart from each other and cause the electron cloud expand. So when the electron cloud of P3 P3 minus is expand, so this means that the anion has larger size than the atoms. Okay, it's time to discuss tutorial question. This time we are going to continue with question number 4C first. The proton number for the several elements are given as follow. Then the question C asks us to compare the radius of element N and also its respective ion. Okay, so in this case means that you are going to predict yourself what is the ion, is the ion a cation ion or an ion? Okay, so if you still remember, we already discussed question 4a in the in the previous video. Okay, so based on the electron configuration is 1s2 up to 4s1. Okay, so because of there is one valence electron, so element N tend to lose one electron to form N plus with the electron configuration 1s2 up to 3p6 only. Okay, so now we need to compare the radius. So the first sentence you can come up with this. Atomic radius of element N is larger than ionic radius of N plus. This one you will have 1 mark. Okay, then 1 mark can be for the electron configuration. Then next we are going to do the explain your answer. Okay, so if you look at the question here, you will notice what I write down here is similar with the previous slide when we discussed about the size of atom and also the cation ion. The difference here is I will include the element N in my explanation. For example, N has greater shielding effect than N plus. Okay, therefore N has weaker attraction between nucleus and valence electron compared to N plus. Okay, we always put in the requirement of the question in our explanation. Because of the weaker attraction, so this will cause the valence electron of element N is further from the nucleus compared to N plus. So that's why end up we have this conclusion. Atomic radius of N is larger than the ionic radius of N plus. So here 1 mark and then here can be another 1 mark. Okay, so just recall back, if we want to compare atom with the cation ion, we're going to use shielding effect like what we already discussed just now. If we want to compare the size between atom and anion, we are going to use mutual electron repulsion. Let's continue with the isoelectronic species. What is the meaning of isoelectronic species? So basically here, they can be atoms of ion that have same electronic configuration because they have same number of electrons. Okay, so look at the electron configuration given here. Let's say Na plus, the electron configuration is up to 2p6, while Mg plus is up to 3s1, Mg2 plus is up to 2p6. So based on above electronic configuration, when we're comparing Na plus and Mg plus, they are not isoelectronic species because they have different electronic configuration. One up to 2p6 and then another one up to 3s1. So Mg plus and Mg2 plus also have different electron configuration. So both of these are not isoelectronic species. Okay, however, if you look at the electron configuration, you will notice that Na plus and Mg2 plus are isoelectronic species because they have same electronic configuration. Okay, so because of they have same electronic configuration, so that's why in this question we are not going to use shielding effect to do the explanation, but we will use the effective nuclear charge in the explanation. Okay, now let's look at more example here. So oxygen have O2 negative have a proton number of 8, fluorine 9, neon 10, and sodium 11, magnesium 12, aluminium 13, phosphorus 15, sulfur 16, and chlorine 17. Okay, after that, let's say all these elements turns to ions. Okay, no matter what is the charge, the proton number is still the same. Okay, even though it is ions. Okay, but when we look at here, 2 negative means that gain 2 electron. The number of electron will become 10. 9 plus 1, 10. For the neon, didn't gain or lose electron, so remain 10. Sodium lose 1 electron, become Na plus 10 electron. Magnesium lose 2 electron, become Mg2 plus 10 electron. And same case happen to the aluminium, donate 3 electron to form aluminium 3 plus with 10 electrons. So when we look at here, all these species from the O2 negative up to Al3 positive here, they have same number of electrons. So when we write the electron configuration, it will from 1s2 up to 2p6. So just now we already mentioned, because of their electronic configuration are similar, so means that they will going to have similar shielding effect. So when they have similar shielding effect, we cannot use this factor to do the explanation why they have different radius. So recall back in the previous video, basically our focus only two factors. One is shielding effect, and then another one will be effective nuclear charge. Okay, since the shielding effect cannot be used in this case, though, then we have to try to use the effective nuclear charge. So 1s2 up to 2p6 here, basically we consider we have two shells occupied by electron, which is n equal to 1 and n equal to 2. So the inner electron, the formula for the effective nuclear charge is proton number minus number of inner electrons. So in this case, 1s is considered the inner electron. Okay, so you will notice at here, we always minus 2 for the O2 negative, F negative, neon, Na plus, Mg2 plus, and also aluminium 3 plus. So all these we are going to minus with 10. Minus with 2, but because of the proton number is increasing, so this also will lead to the increase of effective nuclear charge. Okay, so then as we all already have the idea, if effective nuclear charge increase, means that the attraction between nucleus and valence electron become stronger. So if stronger means that valence electrons are closer to the nucleus. So we will get the idea, the size is getting smaller. So now we look at another condition at where this time we have phosphorus, gain 3 electron, become 18 electrons. Sulfur, gain 2 electron, become S2 negative, 18 electron. Chlorine, gain 1 electron, becomes chloride ion, also have 18 electron. This time when I write the electron configuration, we will write 1s2 up to 3p6. So in this case, we have 3 shells, n equal to 1, n equal to 2, and n equal to 3. So the number of inner electron is the total electron in n equal to 1 and n equal to 2. So when we total up 2 plus 2 plus 6, so means equal to 10. Okay, so then you will notice for these three example, we minus 10, and minus 10. Okay, so at the same time, we also notice the effective nuclear charge increase. Okay, so similar explanation will be used. Okay, but maybe later in your explanation, you have to include the species given in the questions. Okay, so now we're gathering the information above the slide, and then we just focus on nitride ion N3 negative up to aluminium 3 plus, because all these species are isoelectronic species. Okay, and then this is the effective nuclear charge that we just calculated. So based on this effective nuclear charge, then we can arrange this ionic radius in order of decreasing ionic radius. Okay, so because of the effective nuclear charge for the nitride ion is the smallest, so means that there is the weakest attraction between the nucleus and valence electron, so its size is the largest. Okay, the smallest the effective nuclear charge means that the largest the ionic radius, while the positive 11 is the effective nuclear charge for aluminium 3 plus. So the effective nuclear charge is the largest, so that's why the size of the ionic for aluminium 3 plus is the smallest one. Okay, then now we also can come on another one conclusion. Okay, when we notice the more positive the charge, the smaller the species. While the more negative the charge, the larger the species. Okay, this is another summary that we can make. Okay, but I don't think this is necessary for you to remember. If you think that it's confusing, then I think up to this level should be enough already. Okay, it's enough for you to do the correct judgment when you want to arrange the order in either increasing order of ionic radius or decreasing order of ionic radius. Okay. Okay, based on the slide previously, we noticed that we are discussed about isoelectronic, and some of them, for example, the N3 negative up to the neon, they are in period 2. Okay, while then the Na plus up to the Al3 plus are in the period 3. Okay, so isoelectronic, but actually initially their atoms are from different period. So now we are going to discuss the ionic radius, but all the atoms of this ionic radius are from the same period, which is period 3. Okay, to explain the radius of isoelectronic species, so just remind, we are going to use the factor of effective nuclear charge. Okay, so for example, the electron configuration for Na plus is up to 2p6. So number of electron is 10. So effective nuclear charge is positive 9, 11 minus 2. Mg2 plus also have same, but the effective nuclear charge is 10. Aluminium T plus, same case, same electronic configuration, so same number of electron, but the effective nuclear charge is positive 1. Positive 11. Okay, and then next one is the silicon 4 plus, same electronic configuration and number of electron with others ion, but the effective nuclear charge is positive 12. Okay, so as we already know, the greater the effective nuclear charge means the valence electron are attracted strongly towards the nucleus. So means that in among these 4 ion, silicon 4 plus have the smaller size. Okay, so this one here they mention the ionic radii is increased from silicon 4 plus up to Na plus. So Na plus has the largest ionic radii. Okay, after comparing the atoms in the period 3 which can form cation, then now we also want to compare the atoms in period 3 but where this time they are going to become the anion. So same case as well, phosphorus, sulfur and chloride ion, we are going to write down their electronic configuration, and we notice that the electronic configuration is up to 3p6 while they have 18 electrons, which is different from cation. Okay, so just now if you still remember, the cation that we suggest above all contain 10 electron. But for the anion, because they gain electron, so the number of electron is up to 18. Okay, while we're still using the same formula to calculate the effective nuclear charge, again, this time the inner shell is n equal to 1 and n equal to 2. So that's why we are going to use 15 minus 10 equal to positive 5. Same electronic configuration for S2 negative, but the effective nuclear charge is positive 6. While same case happened to the chloride ion, and its effective nuclear charge is positive 7. Okay, so in this case, the ionic radius, which is the smallest among these three, belongs to chloride ion, and P3 negative has the largest size. Okay, now let's combine the cation that form from element in period 3, and also the anion that form from element in period 3 as well. Okay, both atoms are stated in the period 3, okay, which I already mentioned. And then between Cl negative and Na plus, which one has the bigger size? So to answer this question, we are going to write the electronic configuration. So if you still remember the Cl negative, when just now we say they have 18 electrons. So when we write the electronic configuration, it will up to 3p6. While Na plus only have 10 electrons, so when we write the electron configuration, only up to 2p6. So now, try to ask yourself, is it chloride ion and Na plus are isoelectronic? So definitely no, because one have 18 electrons and another one have 10 electrons. So if they are isoelectronic, in this case, do you think that we still need to use effective nuclear charge to explain why they have different ionic radius? Okay, so definitely in this case, it is not, because the number of electrons are different, so means that the shielding effect also different. So in this case, we are going to consider shielding effect. So due to the electron configuration for the Cl negative has 3 shells occupied by electron, while Na plus only 2 shells occupied by electron. So it's very obvious that Cl negative has greater shielding effect, hence the Cl negative have bigger size than Na plus. So when I combine the two trends together, so the trend of the cation will be in the front, and then the trend for the anion will be at the back here. Okay, so we are end for the theory part. So now let's do a very quick summary. So with the important tips given here. If you notice that the question is related to the size or the radius or radii, okay, then you have to first thing always write the electronic configuration and then try to relate with the factors. So generally we have 3 factors. For effective nuclear charge, we are going to write down when across period, we are going to use this effective nuclear charge. And also isoelectronic species, we will use the factor of effective nuclear charge to explain. For the second factor, basically we are going to use when we want to comparing the size between the elements down a group or between atom and cation. Okay, and then the next one, electron repulsion. We will use this factor when we want to discuss between atoms and also anion. Okay, let's continue with the tutorial questions. So previously, question number 4. So now we are going to complete question number B. Arrange this ion in order of increasing ionic radius. Okay, so in question number A, we already have the ion. So L is L negative, while M is M2 negative, and N is N positive. Okay, so 17 gain 1 electron, so we'll have 18 electron. 16 gain 2 electron, 18 electron. 9 element N donate 1 electron, so also have 18 electron. So basically we will have the idea all this ion has 18 electron, so they are going to consider as isoelectronic species. If they are isoelectronic species, means that this time we are going to consider the factor of effective nuclear charge. So when we do the explanation, we have to include the N plus, L minus, and M2 negative in our explanation. So we repeat all these ion we mentioned, we let the examiner know that they are isoelectronic species. So 1 mark here, and then we will going to discuss about the factors, okay, which is when the proton number increase, the effective nuclear charge also increase. Okay, again, when you look at here, we focus on the MLN and also the ion. So means that we are going to put in the element in this question into our explanation. In the notes, you are given the general explanation. So when you're answering the question, just you can use back the same terms in the explanation, but just need to add on the species that given in the question. Okay, because of the effective nuclear charge increase, then we will have the idea the valence electron will be more tightly held towards the nucleus. Okay, so why we want to mention about this? Because this one indirectly let us know the definition of the radius. Wow, then because of this, then we end up the size will be increasing from N positive to M2 negative. Okay, so let's do the very quick conclusion. Identify the trend first. Okay, first to identify the trend means that are they in the same period, same group, or they are isoelectronic. Okay, so are they same period, same group, or isoelectronic, or they are considered like atom compared with ion. Okay, basically we have these 4 groups. Okay, after that, then we mention about based on the trend, we identify the factor. And then the third one, we try to relate with the definition. And then lastly, we come out the conclusion or the arrangement. Okay, let's discuss extra question. This is the previous UPS question. According to the table below, okay, we are given the atoms and also the atomic number. So the atomic number here basically is also considered as proton number. Okay, then they let us know what will happen to the atom if they gain or lose electron. Okay, so compare the size between P and Q with their ions. Okay, so in this case it means you want to compare P and P negative and then Q and Q positive, 2 pair. Okay, one pair is between P and P negative, another pair is Q and Q positive. Okay, so explain. So basically you will see this past year question actually is quite similar with the tutorial question 4C just now. Okay, only every time in the question they will give us different species with the different number of proton numbers lah. Okay, so if we know we want to compare P and P negative, means that we first, like just now we mentioned, we are going to compare what is the trend. So the trend is atom and anion. Okay, so then second, what is the factor that we're going to discuss? So the factor is mutual repulsion between electrons. Okay, that while for the Q, the trend also is the atom but an ion, but this time we can do it more specific, which is between atom and cation. Okay, so after that, then we will know if atom and cation, we are going to use the factor of shielding effect. Okay, now let's look at the answer. Size P will be smaller than P negative, 1 mark. When electron is added into p atom, okay, the mutual repulsion between the electron becomes stronger or increase, another 1 mark. This will cause the electron cloud expand, okay, and that means that the p negative will have larger size than p, okay. The conclusion is already given here, so you no need to repeat, it's okay. So next pair, we are going to compare the Q with the Q plus. So generally, basically, we already know atom will have larger size than Q plus. So now let's look at how we're going to do the explanation. When the electron is removed from Q, the shielding effect of Q will greater. Okay, so again, you see, we can see the word shielding effect. And then you mention which one has greater shielding effect. Q has greater shielding effect. And then makes the valence electrode for the Q plus is closer to the nucleus. Okay, so that's why the Q has the larger size compared to Q plus. Let's continue to the last question, UPS 2007 and 2008. Compare the radius of fluoride ion and the magnesium ion. So when we are given this, if you still remember, just now we say first we must write down the electron configuration first. Okay, if the question didn't give us the electron configuration, so we're going to write down the electron configuration. So after we write down for both the fluoride ion and magnesium ion, we notice they are isoelectronic species. So you have to write it down. So again, from the electron configuration, we know the trend. After we know the trend, then we know that we are going to use which factor to do the explanation. If isoelectronic means that we are going to use effective nuclear charge. So you will look at here, effective nuclear charge of magnesium 2 plus is greater than F negative. Okay, here again means that we have to include the species of the question, Mg2 plus, F negative. Okay, which later they will cause the outermost electron of Mg2 plus are attracted more strongly to the nucleus. Because it is more attracted strongly to the nucleus, then we can have the conclusion that Mg2 plus has smaller size or smaller radius than F negative. So I think that's all for this part, which we compare the atomic radius, atomic or ionic radius between atom and ion, and also isoelectronic species, and also the elements in the group, period 3, when they become the ion. So in the next video, we are going to discuss about ionization energy. Thank you for watching. See you.